Okay, let's have a look at this problem. So, we have an equation of two unknowns, and normally we need two equations, your standard simultaneous problem. However, it is possible in certain cases to solve them when there's only one equation, provided there's some other restriction. And in this case, the restriction is that x and y have to be integers. So can we find an x and y integer so that 172x plus 20y equals 4? The answer is yes. But first we have to check something. First we have to check something with the greatest common divisor between 172 and 20. We can do that using Euclid's algorithm. 20 divided into 172. How many times does that go? 8 times, isn't it? 160. Left over, remainder 12. 12 into 20 goes once. Remainder 8. And 8 into 12 goes once. Remainder 4. And then 4 into 8 goes twice, remainder 0. Don't care about that one. So the greatest common divisor is the last remainder that wasn't 0, which is 4, which is perfect because that's what we have here. And so we can definitely solve this equation using a Euclid method here. What we do is we write each of these three long divisions as equations. So that is, this we can say is 172 equals 8 times 20 plus 12. This is 20 equals 1 times 12 plus 8. And this one here is 12 equals 1 times 8 plus 4. And then we rewrite them as statements about their remainder. So we can say 12 equals 172 minus 8 times 20. 8 equals 20 minus 1 times 12. And 4 equals 12 minus 1 times 8. And then you take the last equation and just write it up the top here. 4 equals 12 minus 1 times 8. And then you substitute in the brackets. So we can replace the 8 with this expression. So we get 4 equals 12 minus 1 times 8, which is 20 minus 1 times 12. So that's 4 equals 12 minus 1 times 20 plus 1 times 12. And notice that we have two 12s we can combine. So 4 equals minus 1 times 20 plus 2 times 12. Now, we move on to the previous equation. 12 equals 172 minus 8 times 20. So we don't replace the 20. There is no equation for 20. There's only equations for 4, 8, and 12. So we don't replace the 20. We can, though, replace the 12 now in brackets. So we have 4 equals minus 1 times 20 plus 2 times 12, which is 172 minus 8 times 20. So 4 equals minus 1 times 20 plus 2 times 172 minus 16 times 20. Notice we have 20s twice. So we can say, how many? And we have 172 times 2. There's only one 172. So we can say 172 times 2 plus, and I have minus 17 times 20. So 20 times minus 17 equals 4. And that's the end because we've no more substitutions to make. And notice that what we have here is an equation that says 172 times 2 plus 20 times minus 17 will equal 4. And remember at the beginning, I said we're looking for x's and a y. so that 172 times x plus 20 times y equals 4. So by directly comparing the equation we formed here with the question, we can see that x must be 2 and y must be minus 17. Let's take out our calculators and quickly check that. 172 times 2 plus 20 times minus 17 does indeed equal 4. And so we've solved this equation. Okay, thanks for watching, and I'll stop the video there.